Hello everyone and welcome back to the channel. Today I will show you how to analyze a malicious password stealer. The infection starts off with a shortcut file which is downloaded onto the system via a phishing email. The shortcut file then downloads a malicious password stealer on the system. The password stealer collects sensitive information from the system and uploads them to the attacker's command and control server. We will analyze the password stealer to collect two different kinds of information. Number one, what are the different kinds of command and control servers where the password stealer connects? Number two, what is the sensitive information it collects from the system? So let's dive in. Here we are in the virtual machine. I have a folder called Malware on the desktop which has two files, step 1 and step 2. Step 1 is the malicious shortcut file which downloads step2.exe and step 2 is the password stealer. Firstly, we will analyze step 1, how it works and how it downloads the password stealer. Since this is a shortcut file, I will use PowerShell to analyze the target and the arguments. I have the Stack Overflow article here which I will use to help me with the analysis. I will open up a terminal and in the terminal I will paste these commands. I will also copy the shortcut path and put it in the codes. So here is the path, and after that I will use the command write -output $target to put the details of the command on the screen. As you can see, the target of the shortcut is running the PowerShell file, and using PowerShell it executes the command of firstly opening notepad.exe, and after that it launches a web client to download a file from iwillcreatemedia.com. The file name is build.exe. It downloads it on the system as putty3.exe. After that it launches putty3.exe and changes the attributes of putty3.exe to hidden. This is quite a stealthy part of the shortcut file. Next we move on to the analysis of the password stealer, which is in fact the build.exe, which is dropped on the system as putty3.exe. To start the analysis, I want to understand some of the basic details of the password stealer. In order to do that, I will drop it inside PE Studio. Once we download it or open it in PE Studio, we can see some information. The first thing that we see is in order to analyze step2.exe, which is the password stealer, I will open it in PE Studio. In PE Studio, I will see some details which will help me further in the analysis process. I can see that in the libraries, it shows Microsoft.NET Runtime Engine, which gives me an indication that this executable is written in .NET. I can also see the signature, which tells me that this is a C# executable, and I can see the version name or the name of the file, which is poulight.exe. In order to analyze a .NET executable, I can open it in dnspy. dnspy is an application which is like a decompiler for .NET applications. I will open the file here. On the desktop, we have the malware folder, and inside we have the step2.exe. Alright, so as soon as we open the file, we can see poulight.exe, and then we can also see the entry loader entry point.main. Now, I can do some static analysis, which means that I can read the code and try to understand what is going on. In order to save some time, I can also go in and collect the code or extract the code from the dnspy and run it inside Visual Studio so that I can quickly extract the information that is needed for the analysis. I will do that right now. So go to here, export to project, and on the desktop I will create a folder called code. Inside this folder I will create the solution. Now I will open the code in visualstudio.net. We are waiting for the code to open. Once the code opens up, I will build the solution. As no decompilation solution is perfect, we expect to receive some kind of an error. I know how to solve this error by just writing this conversion process to convert the output to a byte, to put it in 4 places here, and after that we have another place where I will add this as well. Alright, once this is completed, we will try to compile the code again. After this is done, let me close all these open files and go to the entry point. We will open the entrypoint.cs file and go to the main function. In the main function, we can see that there is a function called checkVM, and after that there is an if condition. Now if the anti-vm.checkVM function returns false, only in that case will this if condition get executed. So let's go into the checkVM function and see what it does. Go to the implementation. The first thing that it does is it checks for the administrator. And how does it check for the administrator? Is by comparing the process name to PLL tests. This tells us that whoever is the administrator of the code, or in my opinion the writer of the malware, he was running the application as PLL test. Now in order to return true from this function so that the rest of the code executes, we will just plainly return true over here. The next thing we do is we check to understand what are some of the other things it does to check for a VM. It runs the WMIC command, which is select star from Win32 computer system, and then it compares the manufacturer to Microsoft system, which looks like it could be the Microsoft Sandbox or Hyper-V or something like that. The second thing, it compares the model string to virtual, or it compares the text to VMware or VirtualBox, etc. It is also looking for injected DLLs. So these are the DLLs which are injected by other sandboxes into the applications which are executed on the sandboxes. So basically here it is trying to do evasion for VMs and sandboxes. If this returns true, again the if condition will not execute, so I'm going to change this condition to false as well. Return false. Okay, so that is fine. All right, we go back to our main function, and here now we know that the main function here, now we know that this if condition will be true and we will start executing this start function, right? So let's go here. In the start function, firstly we see that it is calling buffer start, handle param start, and then there is a check replay start, entry point activation, and XS start. We will put breakpoint here and we'll try to see what the buffer start function does. I will try to go to the implementation of the start method. Alright, in the start method, we can see that the malware author is trying to hide this string by setting it up using the ASCII codes of the characters and this string as well. So let's see what these strings are, and we will also create a notepad document to note down all these values. Okay, buffer.start, and here we are. Let's look at the values. I'm pressing F10 to go further on the keyboard. So the value of sender is, okay, let me copy this and let me start a notepad document here, and I will save this as notes. Desktop malware. All right. The second thing that we will look at is the handler string. So what is the value of the handler string? Copy this and put it here. The next thing is the path L. Let's copy this as well. So I think this is the random folder which is getting created by the password stealer. Most probably I suspect that this is where the passwords or the critical information will be dumped before it is sent out to the attacker's command and control system. So path B, this is another folder which looks like something random. After that we have path T, which is another thing. Okay, this is the temp folder, and after that we have path AD, which is the roaming folder. Path LAD, which is the local folder. DS looks like the documents folder or the desktop folder, documents folder, okay. And DP is the desktop folder. The head looks like a string and we have the buffer data, so that's fine. The next up we have the handle params. Let's go into this function as well, go to the implementation, and we can see here that the code is trying to extract some of the settings. So let's go and debug this function as well to get the values of the settings as well. So the text, this looks like it is base64 encoded. Let's first let the code decode the values and then we will copy them out. All right, so here we are, the value of the settings. Let's copy them here as well. Now some of these values look like they are base64 encoded, and we will look at these values as well. Let's move on and see what else it does. It just sets the file data to the settings and the params to the array which is part of the settings as well. All right, so that's fine. We will exit out of here and let's check the next function, which is check replay start. Go to the implementation. All right, so this I think is creating the mutex, which is to ensure that the code does not execute again. So the buffer path is this, the total path where the mutex will be created is this. Let me copy out this path. Firstly, let me empty the temp folder just to make sure that there is nothing there which will stop the execution of the malware. Right, so that's fine, and this is the mutex. So let me copy out this value as well and put it in our notepad document. All right, so we can continue the execution. and after that we have entry point dot activation, which is coming out as true, and then we have access dot start. So go to this implementation and let's put a breakpoint here. So firstly, it looks like it is collecting some information. Firstly, let me try to reach this function as well. Okay, it's trying to collect some information. So let's go into this function's implementation. And what is the information it is trying to collect? Firstly, it creates a document called PC information. Most probably this is in the same path where app data local, it should be here. You can see that these folders have already been created. So most probably it will dump these files here. And it is also detecting the AV. I don't see anything else being done here. So that is okay. We can let this function execute. So go back. You will let this function execute. And next we have the proc list. First, let's see if there is any values dumped in the PC information.txt. All right, so our PC information has been dumped here. So that is fine. Next is proclist.parse. Let's go into this implementation as well. All right, so we can see that here it is only collecting the processes which are running on the system. So we should be good here. So right now, as I said, the two tasks of our analysis are to get the command and control information and to get the details of the sensitive information which the malware picks up from the system as well. So that is what we are trying to get. So param2 here, let me see what param2 actually is. So I'll dump this directly into a watch to see what it comes to. This comes to 0, so that's okay. So this function will not be executed. Let me go to the next function, cboard.start. Go to the implementation here. In the implementation, we can see that it is creating a clipboard.txt. I think this is copying the clipboard to a clipboard.txt file. In order to see how it works, I'm just going to copy this method to the clipboard and see if the clipboard.txt is created with these values or not. So let's go back and let's see the execution. All right, moving on further, we will reach the desktop image.start. I will go to this function again, to our folder again, and I will see that in the clipboard I can see that the values that I had copied have been copied here again. So that's fine. Next thing is desktop image.start. Let's go to the implementation. This looks like it is taking a screenshot of the current view. So that's okay. Let's go back. So I think we should have a screenshot of the view that we are seeing. That's fine. So what are the next things that it picks up? I accidentally executed it, but that's okay. So it's looking for desktop files, document files, app data, local app data. It's also looking for the disk files, and it goes into the program data, program files, all these things. And it is executing this search files function. Let's look for the search file function. The search file function is here, and it is looking for the files which contain password, login, account, etc. So on the desktop, I have created a file with the passwords as well, temporary passwords and details related to that. Just wanted to make sure and understand whether this file is being picked up by the malware as well. So let's go back again, and the D file has already been executed, so we can go back and see. All right, so we see here that a stealer folder has been created, a stealer files folder has been created, which has our file, the ASK passwords file, and then it is also looking for the disk files, and it is copying the notes as well. Alright, so it's copying a lot of information from the system itself. The webcam, we do not have a webcam. Let's just see if that it is doing anything else. I don't see it doing anything else, so let's move on. FZ looks like FileZilla. Go to the implementation. Yes, it is FileZilla. We don't have FileZilla on the system, so moving on. Pidgin is another software. Let's look at what are the details. It's looking for the accounts.xml, login, password, and protocol. It goes to tell you that this password stealer is quite thorough, and it really wants to capture all the sensitive information a person will store on the system. DS looks like it's Discord. That's fine as well. We don't have Discord on the system. TG looks like Telegram. Again, we don't have this information. Skype, we don't have Skype. Steam, again, we don't have Steam here as well. This will be an exception. That's fine. Does not matter. It will move on. It is also collecting information related to Bitcoin QT. Let me go in and see what this is. So it is looking for Bitcoin QT and then wallet.dat. Basically, it's collecting your information related to the wallet. All right, so that's fine. We don't have that here. It's going to catch an exception. Does not matter. Moving on. So Bitcoin byte dash. It's okay. Ethereum, Monero. So now we have, after that, we have something interesting. We have EGC Chrome C start. I think here is where it is trying to extract the details from Chrome browser. So if directory.format.exist browsers. So yeah, it is trying to extract the information from the browsers, and it is looking for these kind of regular expression based files as well. And if we go down, it is looking for autofill.txt, cards.txt, passwords.txt, cards information. What else can we see here in this code? It is passing the files for the password as well. So it's extracting the URL, login, and the password. All right, so that's fine. Now let's see what is the information that has been collected in the folder till now. We can see this is quite thorough, right? It has collected all this information, autofill as well here. If I go to the browsers, it has collected my cookies for all the Stack Overflow and the GitHub values that I have accessed as well. And it has collected all these details as well, right? Thank God I did not have any cards on the system. Discord, FileZilla, Skype, all these things. So as part of the incident response or the remediation of a system infected with this malware, the user will have to be asked to reset all this information, make sure his cards are secured. If his card information has been compromised, those cards will have to be cancelled and reissued as well. So let's see what happens after that, right? So this is a text. Let's see. All right, so there is another path being created in the user's app data roaming folder, which is N8VCCBQC. So we can look at this as well. Let's go to this path, app data local, app data roaming, and we'll see if this exists or not. And now a zip file is getting created. So we see that this is getting created now. This is a zip file most probably, and if we extract it to, of course, so this has all the information in the form of a zip file. And after that, it is now creating some name value pairs. The name value pairs are being created, and after that we can see here, I can see that the web client will upload these values to resource manager resources.getString.connect, right? So let's see what is the value here. So you can see that the value which is here is this. Let me copy this out as well. So this is one of our IOCs that we wanted to collect. We already have the information that is collected by the system, from the system, by the password stealer. The second goal that we wanted to achieve was to collect the IOCs for the command and control servers. So this is one of those IOCs. We will also analyze these settings string here to extract any details that we want, that we can see from here. And I do not see any more details here, any more connection information here. So it's just uploading the file that was created and the name value pairs. So that's fine. We can stop the execution of the code right now. In fact, let me keep it running, and I will try to extract more information from this as well. So let's go to CyberChef and see if we find some more information from the settings string. So these are all base 64 strings. So let's extract the first string, which is convert from base 64. The first string is admin, so that's fine. The second value that we have is 1, that's also okay. The last value is 0, that's also fine. Poulight, which is the name of the application. CP data, this looks interesting. CP data looks like a key of some kind. Okay. And the UL file. All right, so we have another IOC here. Most probably attacker control box, where it is downloading the secondary or the tertiary payload. All right, so I think we have collected all the information. I just want to make sure whether there is any other information that we have missed. So resources set. I don't see any further information present here. All right, so I think this brings us to the end of the analysis. We have found out the things that were needed from our side. The next step that will have to be taken by any incident response team which is facing this password stealer on their network is that they will have to make sure that the users are updated, that their information has been compromised. They have to make sure that the passwords and the credentials are reset to ensure that the security of the organization is maintained, and make sure that the password stealer is removed accordingly and remediated from the infected systems as well. I hope that this video has been informative for you. Thank you very much for your time.